Let's relate the change in momentum to net force. Well, how do we do that? Well, let's start looking at this. What is net force? M times A. Remember, when a net force is applied to an object accelerates, Newton's second law. Well, somehow we've got to get some momentum in here. Well, what we're missing are velocities. Well, the definition of A, delta V over T. So we have net force equals M delta V divided by T. So we've got some velocities and we've got some masses. Remember, that's what momentum is made up of. So what we can do is substitute in for delta V. Remember, delta V equals V minus V0. So F net equals M V minus V0 over T. Well, let's distribute the M. F net equals MV minus MV0 over T. So let's take a look. We've got some momentum now. MV and an MV0. Looks like a final and an initial. So what does this say? F net equals P final minus P initial divided by T, which is delta P over T. So what this really is Newton's second law rewritten. In fact, when Newton talked about his law, this is really what he said. We look at it as F equals ma, but what Newton really said is when a net force is applied to an object, the linear momentum of the object changes relative to the time the force is applied. This is what Newton's second law is. So a net force will change the linear momentum of an object. Well, let's kind of rewrite this so we can have momentum all by itself. So we can multiply both sides by T. F net times T equals delta P. So what we want to take a look at is this. This term is not momentum. It is change in momentum. That is a big distinction. Delta P means change in momentum, P final minus P initial. If the right side is change in momentum, that means this term also must be change in momentum. So it looks like a net force acting through a time changes the object's momentum. The term F net times T has a name, and that is called impulse. Impulse is the product equal of F times T. This little formula is called the impulse momentum formula, and what it says is this. Impulse equals F net times T equals delta P. And remember, delta P means P final minus P initial. And this is called the impulse momentum theorem. When an impulse is applied to an object, the object's momentum changes by the amount of impulse. So impulse and change in momentum are the same thing. They have the same units. If you remember, delta P, which is kilogram meters per second, was also called a Newton second. Well, if you look at impulse, it's a force acting through a time. That's also a Newton second. So to be clear, impulse is not momentum. Impulse is change in momentum.